Sir, the AI things, the data accumulation, how it will evolve in the AI region.
I didn't get the question again.
Is that AI generation? What is the role of data accumulation? Data models and this NWP models, how they can coexist with AI?
Oh, how they keep going? Did you say how
Yes.
they keep going? Okay. Yeah. Actually, that is better if it's not too close. Just repeat one more time. Are you saying how the model and assimilation system will keep going in the AI?
When the AI system, the coming AI generation, how this data assimilation and NWP coexist with AI?
Okay. See, the data assimilation is, of course, a constantly evolving science, and some of the new research that is being done is to be able to, you can assimilate, data, but also you can assimilate some of the future data, and the benefits you get even for 6 hours is much more that you can get at 24 hours, 36 hours. In other words, you can also use data assimilation to reject data. That's use the dynamics of the model because it seems that a lot of problems are also because of bad data, and you can use the dynamics to do. But this is the conventional. There are two methods that everybody is trying to experiment, right? Ensemble Conwell filter, and also what Noah had started, just to initialize. Since you are going to do for 10 days, now it's very clear also that you should try to get coupled assimilation if we can go. It's not just good for seasonal, but we need to do that now. So far as the AI-based where we're doing directly, there's no assimilation system. They're just simply saying is that they will train the model directly on the original observation. And I think that the resolution of the model and the resolution of the data are not compatible right now, especially if you go to the satellite data. So we do need effort to be able to test ideas. I forgot, are you guys using 4D VAR or are you using Ensemble Conwell filter?
No, we are hybrid methods, sir. Hybrid and several compound methods in which variation is there and Conwell filter also there.
Okay, all right. So these are the standard, the advanced methods that you have. You should also try to make sure that your young people are constantly trained to be able to be exposed to what's going on in the field. And so therefore, because there is doesn't just have to be. There are so many meetings and conferences where new ideas are being presented, and you should try to make sure that the young people get exposed to that on this, and have an open mind, try different things and see what works. That I just said in the beginning, that's the luxury you have. Very few people have that.
Any questions from online participants? Mitra sir wanted to ask something.
Okay.
Sir, please go ahead.
Yeah. Thank you very much for this talk, and it was very refreshing for me because we were talking about 1989, those years, and that's the time I had completed my PhD and joined, and I thoroughly enjoyed working with you, and it was great, really shaping my career and life because I've spent the whole career in NCMRWF, and that initial interaction with you and all the learning how to implement a model, test it. I think it has shaped my career and life. So thank you for the talk. And it was very nice to listen to your talk. And I have a question because you are an expert in predictability and the skill, etc. So I was thinking about this climate modeling, that climate scenarios, where it's going. And still I'm not convinced that these climate simulations, which are like next decades or future, has really some skill. Because if you see the historical period simulation, the models are not able to produce the interannual variability. So what do you think is the future of this climate modeling, particularly different scenarios in terms of centuries, all these things? And there is so much papers published, downscaling, application in all the sector. So still, it's very questionable and it's
Yeah.
very disturbing
I-
because so
I-
much fund is spent. Yeah.
Yes, yeah.
Thank
First
you.
of all, I have a lot of sympathy with your question, let me tell you. And first of all, thank you for coming to the lecture because you are the one person I recognize, from our early days. But let me tell you, when it comes to prediction of climate and predictability, we should really identify the inherent dynamical predictability of the system versus the externally forced predictability. Okay. So the big question in climate change was that the global warming that we are observing and that's going, uh, is it true that human actions like releasing greenhouse gases is causing? So, in spite of all the problems in the internal variability and lack of predictability at 10 days and El Nino, one thing is absolutely proven beyond doubt, okay, that it is an externally forced problem and the global mean temperature, which is going up, is entirely, almost now entirely due to the human activities. So you do. By the way, if you remember, 2007 IPCC was the first time that it actually shared the Nobel Peace Prize. Why? Because after all these years of 25 years, Germany had made this prediction in 1979, but it took all these years to prove beyond doubt that this warming that we are seeing is because of human activities. Okay, so that, but I tell you where I have sympathy for you is that, but that's true for global mean temperature. It's not true for what happens over my village. Certainly not even true for maybe what happens over India. So we get all these models showing that, oh, monsoon will get more rainfall, let's say. Now, if you look at the details, you'll find out that, wait a minute, the Pacific gets warmer in the global warming scenario. That should give drought over India. So why we are getting this result? And then we realize it is because there's a thermodynamic effect of warm ocean, but there's also a dynamical effect of convergence. Models are not good enough yet to give us that confidence. So what we are doing now is that we are simply using model election as a metric of our confidence. Any feature that is simulated by most of the models, then we have more trust in that. Because otherwise, you are absolutely right. There's no way to how do we distinguish. So therefore, my position has been, and that's another reason I'm always pushing both IATM, but also USA. We must put a lot of effort on seasonal prediction because when it comes to society, we don't know what will happen in 50 years. But that season after 50 years, society will know, will feel that. Okay. So, I mean, there are some decisions for which we need to know. So, I really think that if I know, I always say, I used to give my lectures by there are three revolutions in 20th century in our field. Okay, one is I talked to you about. Okay, that weather is predictable by computers and models and so on. But then it was turned off by butterfly effect. That oh no, we cannot predict. But then we showed that no, seasonal time scale is predictable. So I consider that another, and that's where the whole prediction of monsoon. But then there is a third major revolution, which is to demonstrate that it is the models have shown that the human-induced CO2 is causing climate change. I mean, you cannot imagine how big this result is. I was in Paris Climate Conference, okay, as a part of the India's delegation, as a part of it. And 189 countries are willing to say, we will do these things because scientists are saying that it is because of the CO2. And that was a result obtained by these models. So I agree with first part of your thing. We have to be skeptical about the details, the regional details, but we really have to applaud. And by the way, the region of the Berlin meeting, we wanted to have 1 degree models in that. We wanted to confirm that even the global warming prediction is still supported by cloud convection resolving models. But that's a good, it's a good question, but this should not lead to denial of climate change. Do you know what I'm saying? Which it has done to many people. Yeah.
Just to add to that, see, I got your point. There is no disagreement that climate is changing and model is able to capture the global mean, the warming, that part is fine. See, my question is, because you are an expert or you may be having some intuition, like you always say, subseasonal prediction, if the models are perfect, initial conditions are good, resolution is good, one day we can achieve the skill theoretically, we'll reach there soon, subseasonal to seasonal. So my question is, even if we have a perfect model, everything, this regional variability and interannual variability, do you think in the decade, in the century scale, will we ever be able to capture this theoretically, and whether it will be possible or not?
That's a very good question. Let me just tell you, the progress beyond weather is very slow. So if you review the literature, the predictability of MJO, right? There's a huge project. S2S project. It is so slow, but it is happening. I mean, look at the European Central Model now, has a pretty good skill in predicting MJO. Okay. I think that we are getting the seasonal prediction. I mean, it's really puzzling to me that why the community has dropped seasonal predictability as a scientific question to be investigated. I have look at NOAA. They thought because ENSO was predicted correctly in 97, 98, they thought problem has been solved. I'm having a constant, just like we'd had a major effort in doing NWP, we need a major effort in studying the predictability of seasonal. Just tell me how many groups there are 30 groups who are doing weather prediction. How many groups are doing predictability of seasonal? Very few. And it's just like, oh, we are also doing this. So I totally share with you, but I remain an optimist. And I remain an optimist because we know the equations, and there will be a limit, and there will be uncertainty, and there will be a cone of uncertainty within that. But my concern is we're not making that progress that we should have in predicting.
Okay. Thank you. Thank you very much.
Yeah.
I have one question. Small one. Whether in your opinion, resolution is important or for NWP or in the medium range scale or the coupled models are important?
Oh, repeat again. From what time scale?
The medium range.
Medium range.
Medium range. Oh yeah. Okay. Let me tell you that 20 years ago, I gave a lecture, and people thought it was crazy. I just said, look, weather prediction every prediction has to be done by coupled model. Okay? Just because you are able to do reasonable job without coupling doesn't mean coupling is not important. Coupling is what is happening in nature. There is an ocean and the fluxes are coming out and they are, so just because, absolutely, the answer is no doubt about it. And I have been saying that for more than 20, 25 years, that we should. Now, you do not have to have a deep ocean and you do not have to have a very time-consuming, multi-layer deep ocean dynamics, but you must take the interaction between the atmosphere and ocean. So if you can take care of by a mixed layer, that's good enough. But you must be able to feel that, atmosphere, there's an ocean below, and ocean must feel there's atmosphere above that. And that's very important from India, by the way, let me tell you, because Indian Ocean is one of the few places where if you prescribe the sea surface temperature, you get such bad results in the Western Indian Ocean. Look, Indian Ocean is so warm, but there are no clouds. Just watch this fact that the warm Indian Ocean has no cloud. What does it say? It says that dynamics is very important. So I'll say that we need good. My answer, one-line answer is yes, we need couple models, but not necessarily deep dynamical ocean models, but mixed layer models.
But if you are constrained, you have a computing is a constraint. So you will choose resolution or the coupled. Which one you will choose?
I did. Somehow the sound is not coming so slowly. If you can ask again.
No, it can keep. If you are asked to choose between the resolution and the coupling, so which one means a graph system model or a decoupled model?
Okay.
Resolution. Which one?
I see. Right. You are saying is that if you have to choose between resolution and coupling, okay. First of all, I just don't buy that one has to choose, because look, this is a research topic. You do both. I'm not saying about first you demonstrate what we're doing, but once you have demonstrated, because that you need, there should not be a choice. And why should there be a choice? You tell me. India just purchased a very powerful supercomputer. There's no dearth of supercomputer time. Why there is a choice?
Actually, because many times in the operational center, we are limited within the computing power. So because we have to finish all the tasks within a very short span of time. So many times we have to.
No, that's sorry. I'm sorry. I'll say you manage. You change your system of how do you manage and use your time, but don't sacrifice either resolution or coupling, because okay, let's say you have to delay the window. I mean, see, the science will not advance if we keep making compromises because we didn't have enough operators and we didn't have enough processors. And I mean, I don't think that should be a choice. And particularly when I see the amount of money India is spending on computing, I don't see why time should be a problem. But again, I'm not an expert. I'm just saying this as I'm almost putting a bureaucrat's hat, as if, why should we make such a compromise? But first test it, whether your couple ocean will do it or not. You don't have to start doing the operation. Only, and for testing, there should be no problem.
I have a question. Respect to forward. You talk about AML and you talk about this.
Mr. Lee, I can't hear. Let's see. If I see the person, maybe I can.
You have predictable. So anybody have thought of what is the predictability of the AML technique?
So
okay, now I can see you, so I can read your lips also. So tell me again.
Yes. I am also studying on that. You talked about the AML technique and you talked about the predictability. So anybody has thought of the predictability of AML technique?
Oh, you mean AI and machine language?
Yeah.
Machine, okay. Yeah, so this is a very good question. Let me tell you, you have to distinguish between predictability and prediction skill. AI models are no good for doing predictability studies. You cannot do predictability studies with AI models. That's one of their models. In fact, a new paper has just been published that shows that AI models, that's one of their weaknesses, do not show the butterfly effect. No, so they are good for skill score. That's why they are good for, selling bananas. They are good for selling umbrellas, but they're also good for telling farmers what to do. But their skill is high, not their predictability. By the classical, because they're not subject to the predictability calculation. The system doesn't allow. But see, this is, yeah, just I want to complete that. This is the problem we have. Society doesn't care about predictability. Society cares about prediction skill. And that's what they are beating our models. Yeah, go ahead. Somebody had a question?
Yes, I'm Srinivas. No, this is good. I think you can hear clearly, right?
Yes,
Sir?
yes.
Thank you. See, we have been coming from the dynamical system and we are understanding the weather and we are incorporating into the dynamical system all the changes. Now the AI/ML, the machine learning is coming and understanding the same dynamics what we understood as a human being. So are these ML, the machine learning is much better than the human intelligence in understanding the weather?
No, absolutely not. Let me tell you, my criticism of AI ML is it doesn't help us understand dynamics at all. That's why I don't actually like it as a future. But I keep repeating to you, but society is not going to think about understanding. Society is going to think about skill score. How correct was your forecast? And they're doing that. So this is a big distinction as a researcher. That's why I want dynamical models to remain. I want and we want to be able to ask science questions. You cannot do any of that with the AI. AI ML is just good for getting a result. And they keep increasing, the tuning. I mean, I was in this meeting and I heard that, do you know how many parameters they used to fit 50 billion? Now they are fitting trillions of parameters. And they keep going to different layers, neural networks, and they keep getting better and better results. So it's just no contribution to understanding. Totally agree with you.
Anyone has another question? Yeah. Stop it.
Am I audible?
Stop the money.
Am I audible?
Yes.
Sir, my question is for the prediction skill beyond seasonal scale, how much the deportation dynamics and CI's dynamics is important? And if second part of the question, the research in the field, is it sufficient for pace for moving towards interannual to decadal scale prediction?
Okay. So did you mention CIs in your word?
Deportation dynamics as well as CI's dynamics.
Yeah, right. So that's what I thought. No, this is the data, the evidence till now to be able to show predictability beyond seasonal, okay, is only truly demonstrable for ENSO, okay, and there is maybe something for the Atlantic decadal variation, but it is nowhere near. It's just an active area of research, particularly about CIs. CIs is one of those things where the interaction is so strong. CIs can affect local weather very, very well, and people are doing that. But then within a matter of 2 weeks or so, the flow circulation affects the CIs. Okay. So it's a so therefore possibility of predicting beyond the season is just is not, there's no demonstration and there's no basis right now to be able to do. So far as the prediction of decadal variations is concerned, okay, decadal, I will share with you my own skepticism. I still have not seen any demonstration that there is any predictability at decadal time scale beyond the one that is due to the external forcing by greenhouse or by volcano or by aerosols. Okay. In other words, the internal dynamics of the system, I have not seen, but there is a big community that is working on it. Okay, well, I really appreciate that. I think it is the 15 minutes before. And I really want to thank you guys very much for this very nice conversation. Okay. Oops.
Sir, we are so much thankful for coming and lecturing us.
Can you put the people?
Yeah.
So I just want to thank you all, and I just want to say goodbye to everybody. Thank you, and definitely I'll come. Okay, bye.
Thank you.
Thank you so much, sir.
You're welcome. Most welcome.
Thank you very much, sir. Thank you.
Okay, thank you,
Yes.
Sheila. Thank you, Sheila. Thank you.
Puneet was
Oh,
there.
Mr.
Thank you,
Seth. Mr. Seth, thank you for coming.
Yeah, I'm
Puneet.
here. I'm listening.
Oh, yeah.
I'm
We'll
and
talk
taking
again.
some notes also
Oh my God.
to
Okay.
quiz
I
quiz
can-
you later.
Okay. Sure.
Yeah.
Okay. All right. And
Okay.
some of my friends joined. That was so great. Okay. All right. Okay. Bye.
Thank you.
Thank you, all the online participants.
Hey,
for,
all right. Yeah. Hi, Sunil. Yeah. Oh, so nice. So I like this where I can see a lot of my friends and colleagues now, although we are not together. This is the good part of the. But I still believe in meeting, and I do plan to come to Allahabad sometime. By the way, so we'll definitely meet on the. By the way, I'm sure you guys know Allahabad just got a center of excellence and for monsoon research on the congratulations. By the way, that was good. Okay. And Prasad, thank you so much for making all this arrangement. Okay. Bye.
Bye.
Thank you.
Bye.